All right, hey, seventh grade, we're going to talk about investigation 1.4 a little bit. This should be pretty quick. I posted questions about what was different about these relationships comparatively to the last investigations that we've done. And what you should have known or realized is that our Y values are decreasing every time our X values go up. In past activities, the value in the Y column has always increased, and today they are decreasing. So we have a situation here with Mr. Chang's class and money in their account at the end of each week. So we see that at 0 weeks, they have $144. So at the very start, it says for A1, it says how much money is in the account at the start of the project. Well, we know this is the start of the project because it's 0 weeks, and we know that there's $144 in the bank or in the account at that time. How much money is withdrawn from the account each week? So we see this pattern again of change in the Y value to change in the X value. So every time the weeks go up by 1, the money in the account decreases by $12. So subtract 12, subtract 12, subtract 12, subtract 12, or you can think of it as adding a negative 12 as well. When you made your graph, it should have looked like this. So take note of the x-axis. So in this case, we know that the weeks are our independent variable. We know that because we were given a data table, it's on the left side of the data table, and that is typically where we see the independent variable. And then the money left is on the y-axis. It is the dependent variable. The money depends on what week it is. The money in the account depends on how much time has gone by. Just something to note with your graphs, please make sure that you are scaling appropriately. So I know that this is decreasing by 12 each time, but it's not very common to have a scale that goes up by 12. What would have been appropriate is if you went up by 10s or if you went up by 5s, depending on how much room you had. Typically graphs go up by 1s, 2s, 5s, 10s, 20s, 100s, things like that. Please do not get in the habit of making your graph go up by whatever the change is, because that could potentially mess you up as we move further along with our linear relationships. Okay, so my graph looks different, right? So instead of starting at 0 or starting at a number and the graph increasing as we move from left to right on the x-axis, we don't have an increase, we actually have a decrease. So we have the same kind of stair steps that we've seen previously, down 12, right 1, down 12, right 1, down 12, right 1. That correlates directly to the relationship we saw in the data table. And we know that at 0 weeks, we have $144 in the bank. So at my starting point, 0 is at 144, and then I move down every single week. It goes down by $12. So if I extend my graph, if I get a few points on there and then pull out my straight edge, I can make a nice straight line that brings me all the way back, all the way down to when I have $0. The equation that goes with this. So there's a couple of different ways you could write it, but I want to make sure that we are keeping kind of the same patterns that we saw previously. We know that there are 2 variables. I used M to represent the money. So you could have used a different variable. Just make sure you explain what that variable is. That M is going to go on the left side of the equation, or it could go on the right side, but on one side of the equation you have M, what the money is equal to. So the money is equal to your y-intercept, your starting point, $144. You can actually write this 2 different ways. So $144 minus $12 per week times the number of weeks. So W is what I used for my number of weeks. I put a couple of notes here So I talked previously about how it's like this is very important, the 0, 144, because that is going to be represented in your equation, what gets added or subtracted from the term that has the rate of change and the independent variable. So 144 comes from the y-intercept. Y-intercept is wherever x is 0, so where it crosses the y-axis, where the line crosses the y-axis. The 12, or you can even think negative 12, comes from the rate of change that we saw in the data table. And we can see it here on the graph as well. Down 12 over 1, down 12 over 1. So this is really like saying, I have down here change in y over change in x. So the change in y is 12. The change in x is 1, which 12 over 1 is equal to 12. So we kind of simplify it there. The other thing you could have done, you could have had m is equal to negative 12 times w. Since we are going down, I'm sorry, this up here should have been negative 12. Negative 12 over 1, negative 12 over 1. So it's like we're adding a negative, or that is the same as subtracting. So that's how it's represented here. You could also write it as the money is equal to negative 12 times the weeks plus $144. So we start with $144, and then what happens is we're adding a negative every single time that we go down. If you wanted to check your equation to see if it works out, all you have to do is pick one of the number of weeks that you know the value for. For example, if I go to 2, I know that at 2 weeks it's going to be $120. So all I would do is I would plug 2 into W, and then I would solve it to make sure that my money was $120. So that is a 1, or A1 through 5. 5, we do see that it's linear because we have that constant rate of change. All right, let's talk about B really quickly. I don't have it written out, but I'm just going to kind of go through this a little bit. So Mr. Maymer's class also raised money for the walkathon. They used the money to buy games and puzzles for the children's ward. Keenan uses a graph to keep track of the money, or the amount of money in the account. So what information does the graph represent about the money in Mr. Maymer's account? Well, the graph tells us that they had $100 in the account, and we also can see that in 10 weeks, the money was at 0. So every week they spent a certain amount. We can see in this case too, that we're going down 10 every single week that passes. So down 10 for 1 week, down 10 for 1 week. So my rate of change is going to be a negative 10. The data table that looks like, that is here, looks like this. So I'm going to see if I can actually get both of them on here together. Nope, I can't. That's okay. So the data table, you can see that pattern, right? We start, here's my y-intercept. I start at 0, 100, and I go down 10, down 10, down 10, down 10. Every single time my week goes up by 1. So I've got two pieces of information. My y-intercept, or where my starting point is, it's at 100. And then I know that my change in y over change in x, this little delta sign means change. So that little triangle, little delta y over delta x, change in y over change in x, I'm going down 10, or a negative 10 over 1, which is negative 10. These two pieces of information will create our equation. So if you think about the equation, you're going to have two variables. In this case, they have used A for the amount of money, and then they have used N to represent the number of weeks. I'm going to zoom in on that equation a little bit here. It's in the answer key. So if you have, pardon my phone ringing, you'll see the amount of money is equal to negative 10 times the number of weeks plus 100. So this is one way to write it. Another way you could write this is A is equal to the $100 in the account minus 10 times the number of weeks. Those are two different ways that you can do it. These are both linear relationships as well. So A and B. B, we know it's linear because we're seeing that rate of change in the data table. It's a constant rate of change. And then we also see in the graph that we create a straight line. So as long as our scale looks good, we see that the line looks good as well. So I only asked you to do A and B for this one. So that wraps it up for today. If you have any questions, you reach out to me and you let me know. Have a good one. Bye-bye.